Welcome back, tech enthusiasts. Today, we're diving into the world of Raspberry Pi to create our very own NAS, or Network Attached Storage. NAS is essentially a centralized storage solution that allows multiple devices on a network to access and share files. It's affordable, energy efficient, and incredibly customizable. Setting up a Raspberry Pi NAS is easier than you might think. All you need is a Raspberry Pi board, preferably with a higher RAM, a micro SD card, a card reader, a power supply, and an external hard drive or large USB storage. Once you have gathered all the hardware, it's time for the software. Let's get started. Like Windows or Mac, your Raspberry Pi needs an operating system to work. First, we will need to install a Raspberry Pi imager. To create the operating system, follow along. On your favorite browser, search for Download Raspberry Pi Imager, and from the official website, download and install according to your operating system. Now, we will connect our memory card. A 16GB card will work perfectly. Next, select your device, which is Pi 4 with 4GB RAM in our case. You can choose according to your device. Choose the operating system as Raspberry Pi OS Lite, without desktop. Finally, select the connected memory card. Be careful here to choose the correct card, as you may lose your data. Then, press Ctrl-Shift-X to open Settings. Here, enable SSH and set a username and password for your Pi. Awesome. Click on Next and your operating system will be installed on your memory card. This may take some time, so be patient. Please note, after successful installation, you may get prompted to format your SD card. Ignore that warning, and simply remove your SD card from your system. With the operating system installed, it's time to finally connect our Pi board. Insert the memory card with the operating system. Next, attach a network cable, and finally connect it to the power. We give it some time to boot. Now, it's time to find the allocated IP address. Open the admin page for your router, see the latest connected device, and verify the allocated IP. We can now open a command prompt. On your keyboard, press Windows R, type CMD and hit Enter. Use the following command, SSH, space, username, @ IP address. Click Enter. Select Yes, and type in the password. Here you are, wirelessly connected to your Pi board. Once we are connected to the Pi, we will start by updating it to the latest version, and installing Open Media Vault. Use the following command, type sudo apt update, and hit Enter. Once done, type sudo apt upgrade, hit Enter. This will take some time, depending on your connection. Next, it's time to install Open Media Vault, which is our open source software. Use the following command to install it. This is longest part of our programming. This may take at least 15 to 20 minutes. So be patient. Alright, we can now see Open Media Vault is installed. After installation your IP address may change, you can check it like shown before. Now, we can log in to Open Media Vault server. On your favorite browser, visit the connected IP. We will enter default username and password, which is admin, and Open Media Vault. Let's do some quick settings. Follow along. We start by changing the default password. Keep this a professional and strong password. We will now do some quick settings. To start with, locate Update Management under System Settings. Click on Updates to see available options, confirm and select Yes to proceed with downloads. Next, We will click on System Settings, Certificates, SSH, and create a new SSH certificate using the plus icon. Select type as AD25519, give it any tag and click on Create, and sure to click on Confirm configuration changes henceforward. Same as SSH, we will now click on SSL, create a new certificate by clicking on plus icon, selecting your country, then Create, and finally confirming configuration changes. Now, locate Workbench under System Settings, enable SSL by clicking on the checkbox, selecting certificate we just created from the drop-down, clicking Save, and confirming changes. At this stage you may be prompted to log in again. If so, simply log in again on a new window. Now, we can attach our external hard disk or any large USB with our Pi board. In our case, we are using an old 128GB SSD. Let's connect it to Pi 2.0 port marked in blue. Alright, we will now come back to our server. Click on Storage from the left panel, then Disk, and see if you can find your new connected SSD. Before we mount this, let's do a quick format. Select your hard disk and click on the erase icon, and confirm. Once done, click on Close. We are now ready to mount our drive. We will again click on Storage, then File Systems, click on plus icon, select ext4, choose the drive from the drop-down, and click Save. This will take some time depending on the size of your disk. Once done, we can add a tag. Let's call it D1, select the file system and hit Save. You can now see the disk online. Finally confirm changes. So, our drive is now mounted, but not yet usable. So let's create a user. Like before, click on Users from left panel, create a name and a strong password that you can remember. Once again click on Save, then confirm. Next, let's create a folder user can access. Go to Storage, Shared Folders, and click on plus icon to create one. Name your folder, select Disk under File System, leave the permissions as default. Hit Save and confirm the changes. Now, go back to User section, select user we created, and click Shared Folder Permissions, assign Read and Write, and click Save and confirm. Great, we now have a user in a shared folder. Let's activate network services. Head over to Services. If you are on Windows, click on SMB, CIFS and click on Settings. Check Enabled, make sure Browsable, Use Send File, and Asynchronous is checked. Once again hit Save, and confirm changes. Now, come to the Shares, and create using plus icon. Select the shared folder we just created. Ensure Browsable, Inherit ACLs, Inherit permissions are checked, ensure Public is set to No. And again, hit Save and confirm. Alright, if you have done everything correctly, you should now have a fully functional network storage, and your shared folder should be visible on the network. Let's map our folder as a drive. Go to this PC, right-click to select Add a network location, then click Next, Next again, and under two backslashes, followed by the IP address, another backslash, and the name of our shared folder. Click Next. It should prompt for credentials, use the ones we created in the server. And there we go. We can now successfully access our folder. Lastly, let's do a quick test. We will paste some random 100 megabytes data to see transfer speeds. As you can see, we can move our data at decent speeds. If possible, consider 3D printing a case for your network storage, to keep things organized. Open Media Vault offers numerous customizations, dashboards, and settings for you to explore and learn. Feel free to comment for questions or support needed. As always, you can find the links to commands and STL files in the description. Keep tinkering.